Welcome to this explainer. If you've been waking up with brain fog, struggling with mid-afternoon fatigue, or just feeling that slow, heavy drag of burnout, well, you are absolutely not alone. Today, we're moving way beyond those superficial health hacks. We're going to map out the interconnected biological universe inside of you. We'll be reasoning from first principles to understand exactly how your autonomic nervous system, your sleep architecture, and your cellular biology are continuously writing the script of your physical and mental resilience. So, what if the way you breathe, sleep, and move is secretly restructuring your brain? It's a profound question, right? But the answer is surprisingly literal. Your daily habits, they aren't just affecting your transient mood. They are physically altering the density of the gray and white matter inside your skull. To truly optimize our biology, we have to look past simple tricks and understand the human body as one incredibly reactive, interconnected landscape. Every breath you take and every hour you sleep is either fortifying your neural architecture or it's actively tearing it down. To understand how these microscopic changes cascade into massive long-term consequences, we first need to look at what happens when this biological system is pushed to its absolute limits. Which brings us to Section 1, decoding the allostatic load, the invisible weight of physiological stress. We've all felt psychological stress, but we rarely appreciate the very real, very physical structural damage it leaves behind in our cells. When your body encounters a sudden threat, it adapts rapidly through a survival process called allostasis. But imagine a car engine that is constantly redlining, day after day, without ever shifting gears. When your body is forced to maintain stability through prolonged, unyielding stress, the constant flooding of hormones like cortisol and adrenaline creates a systemic, crushing burden. This cumulative biological wear and tear is what we call the allostatic load. It's literally the visceral, physical degradation of your biological systems in response to modern life. Now notice how elegantly this breaks down the biological cascade. Chronic stress doesn't just feel bad, it physically manifests as measurable systemic dysfunction. Prolonged cortisol hyperactivates your neuroendocrine system, which fundamentally drives cognitive decline. But the damage doesn't stop there. It bleeds into your cardiovascular system, accelerating wear and tear on your blood vessels. That vascular stress then pushes the metabolic system into cellular energy failure and insulin resistance. And critically, this metabolic collapse drives up markers like CRP and IL-6. These are the markers of a body on fire, a state of chronic, systemic inflammation that actively accelerates neurodegeneration. One system falls and it just pulls the rest down with it. To measure this systemic stress in real time, we look at heart rate variability, or HRV. This is essentially the ultimate sign of a resilient, youthful nervous system. A flexible, highly variable heart rate means your autonomic nervous system is incredibly adaptive. It possesses the ability to slam on the physiological brakes after a stressful event and quickly toggle you back into a calm, parasympathetic state. On the flip side, a low HRV signals a rigid, aging system, heavily burdened by chronic allostatic wear and tear. It's a highly sensitive proxy that warns us exactly when our biological engine is redlining. Moving on to Section 2, the vago-respiration switch. Hacking your autonomic nervous system. Fortunately, your body has a built-in switch to halt this allostatic decay and shift you back into that parasympathetic dominance. And it turns out, the magic number is 6. Research into the baroreflex sensitivity threshold shows that slowing your respiration rate to exactly 6 breaths per minute optimally lowers blood pressure and increases vagal tone. At this precise frequency, roughly a 0.1 Hz rhythm, you're optimally triggering stretch-activated mechanoreceptors in your blood vessels. You are essentially using the mechanics of your lungs to massage your cardiovascular system into submission. By engaging in diaphragmatic breathing with an extended exhalation, you are initiating RVNS, or respiratory vagal nerve stimulation. Honestly, this is the ultimate biological hack. You are literally tricking your brain into feeling safe. By controlling your diaphragm, you send afferent signals up the vagus nerve to the central nervous system, hijacking your neural circuitry to forcefully inhibit the stress response. You're using a voluntary physical behavior to force an involuntary neurological reset, creating a powerful biological loop of deep relaxation. All right, Section 3, the brain's night shift, how the central nervous system cleanses itself. By using respiration to calm the autonomic nervous system, we set the perfect stage for the restorative phase of our day. Because sleep, it is absolutely not a passive shutdown. It's an incredibly aggressive, highly active, biological cleansing process. Central to this awe-inspiring process is the glymphatic system.
Think of it as a high-pressure power wash for your central nervous system. Driven by the rhythmic pulsation of your arteries, cerebral spinal fluid is propelled deep into the brain, mixing with interstitial fluid. This high-pressure exchange flushes out the neurotoxic byproducts of daytime consciousness. Crucially, this clears out the exact amyloid beta and tau proteins that are directly implicated in Alzheimer's disease. The stakes of a good night's sleep are incredibly high, and this entire operation is tightly regulated by your suprachiasmatic nucleus and the timely secretion of melatonin.
And here is the truly mind-blowing part. During deep, non-REM slow-wave sleep, your brain's interstitial space physically expands by 60%. Just let that sink in for a second. The physical architecture of your brain actually changes shape to drastically reduce hydraulic resistance, allowing a massive surge of fluid exchange. If your sleep architecture is fragmented, you miss this 60% expansion. You literally wake up with metabolic refuse trapped inside your brain tissue. This toxic buildup is the exact biological root of the brain fog, grogginess, and poor focus you feel the next morning. Counterintuitively, gravity and posture play a massive role in this biological power wash. Dynamic contrast MRI reveals a fascinating evolutionary mystery. Sleeping on your lateral side, particularly your right side, actively optimizes this lymphatic transport. The current hypothesis suggests this relates to optimal heart positioning and sympathetic tone, allowing maximum venous return. This right lateral position is clinically correlated with higher cognitive scores. Conversely, sleeping flat on your back elevates intracranial pressure and heavily impairs waist clearance. It's a highly inefficient posture that has a strong negative correlation with cognitive health. So much so that patients with advanced neurodegenerative diseases like Parkinson's are frequently observed sleeping in this exact supine position.
Let's look at Section 4, BDNF and Neuroplastic Resilience, Fortifying the Neural Architecture.
Once the brain has successfully cleared out the metabolic trash overnight, we shift from clearance to construction. During our waking hours, the brain relies on physical movement to trigger the growth of entirely new, resilient neural pathways. This sequence highlights a beautiful biological paradox. We actually have to apply physical stress to build resilience against psychological stress. When we exercise, we induce a healthy energetic demand. This muscular exertion produces lactate and ketones, which cross the blood-brain barrier to trigger the massive release of BDNF. You can think of BDNF as miracle grow for the brain. It directly stimulates synaptic growth, enhances memory formation, and acts as a neurological shield, making your neurons highly resistant to future injury, disease, and emotional volatility. You know, everything we were taught in high school biology about lactic acid was actually wrong. We used to think it was just a toxic byproduct that caused muscle fatigue, but the modern scientific consensus has completely flipped. We now know that specialized brain cells called astrocytes actually absorb this exercise-induced lactate to powerfully fuel neurons and potentiate NMDR receptor signaling. Lactate is not a waste product, it is a master signaling molecule. It's a critical switch for learning and long-term memory formation. By pushing our physical bodies to the edge, we provide the exact energetic substrates our brains need to adapt. And finally, Section 5, Rebuilding Neural Architecture, the Structural Biochemistry of Repair. So, how do we physically rebuild these pathways once BDNF signals for growth? A blueprint is entirely useless without the raw physical materials needed to execute the construction. Think of your nervous system like a massive electrical grid. Myelin is the protective, fatty insulation wrapping around your nerve fibers. It allows electrical impulses to travel seamlessly at lightning speeds. When myelin degrades, it's like having frayed wires. Your physical and cognitive signals literally short-circuit, which is exactly what we see in neurodegenerative conditions. Producing and repairing this myelin is an incredibly demanding process, requiring massive amounts of ATP cellular energy and highly specific nutritional cofactors. Your brain simply cannot maintain its physical structure without the right raw materials, and the tragic reality is that the modern Western diet leaves us completely starving for these exact cofactors, stalling our neuroplasticity. Vitamin B12 is absolutely non-negotiable for the methylation cycle that synthesizes myelin. Omega-3 fatty acids, specifically DHA and EPA, are the literal physical building blocks that provide fluidity and integrity to your brain's cellular membranes. Without coenzyme Q10, your mitochondria cannot pump out the continuous ATP energy required to fuel this massive repair effort. And finally, magnesium acts as the ultimate neurological gatekeeper. It physically blocks NMDA receptor channels to prevent the toxic influx of calcium that leads to severe oxidative damage. If you lack these nutrients, your brain simply cannot heal. As we zoom back out, the grand biological symphony becomes incredibly clear. You absolutely cannot out-supplement a dysregulated, overly sympathetic nervous system, and you certainly cannot out-sleep a diet devoid of vital neuronutrition. From the precise frequency of your breathing rate, to the gravitational posture you assume in bed, to the molecular building blocks on your dinner plate, every single mechanism we've explored in this explainer is inextricably linked. True health span requires the optimization of this entire continuous cycle. Understanding the deeply interconnected science of this explainer empowers you to take absolute control of your cognitive and physical health span. The mechanisms are no longer hidden mysteries. So I leave you with one vital question to consider tonight as you prepare your mind and body for sleep. Based on the interconnected reality of your own biology, are the choices you made today quietly building your neuroplastic resilience, or are they slowly accelerating your allostatic decay? The choice and the biology is entirely in your hands.